Physical science is the study of non-living things. It's the ability to use logic and reasoning to explain what goes on in the world around us. It's also the study of matter and its motion and behavior through space and time, along with related concepts such as energy and force. Physics looks at how things happen, and it's the reason why things happen. We can also discover more about how stars are made and how we can generate energy and power for ourselves. Have you ever wondered what would happen if your tongue stuck onto an ice-cold frozen pole? How is sound and light energy important to our existence? And can we exist with one and not the other? How does gravity, electricity, and magnetism affect our natural world? How and why substances combine or separate to form other substances? Chemistry deals with a lot of things. We ask questions like, how can the car move? What is providing the forward motion? How are the wheels even able to turn? How high can a ball that was thrown move upwards? Why doesn't oil and water mix? Where does the white light on the stage come from when all I can see is different color lights? physics is just applying or finally using all of the tools you have accumulated throughout your education to figure out the way the world behaves. Take chances.
Good day, grade 10 learners. Welcome to our physical sciences. I am Skulile Ngube. In this lesson is proudly brought to you by the Gauteng Department of Education. Right, we are going to look at wave, sound, and light, and we're going to look at the electromagnetic radiation, and we're going to be calculating the energy of a photon. If you check last week, we started electromagnetic radiation, but we mainly concentrated on the what? On the wave-like nature of the EM radiation. So in this lesson, we're going to concentrate on the particle nature of what? Of the electromagnetic radiation, and also including the calculations that are involved there. But also we're going to be revising questions from past examination papers. Okay, we are concentrating on calculations, but we're going to revise everything that we get in the examinations. Okay, right. Let's be ready for our lessons. Grade 10s. Let's make sure that we can ask questions. Use the line 079 578 2908. Your input is very, very important. Grade 10s, please. If maybe you are moving fast, and also maybe you find there are other ways we can make our lessons effective, please do send us that input. Okay, it's very, very important. Right, so at the end of this, you should be able to define a photon. I know we have done some of the revision lessons where we talked about the photon, and then use Planck's constant when calculating energy of a photon, and then we're going to calculate energy of a photon from past examination papers. We're going to revise electromagnetic radiation topic using past examination questions. This is what we're going to do in this lesson, okay? Right. Now, in grade 10, we've done wave, sound, and light. Now, when we talk of electromagnetic radiation as a particle, we refer to the photon. When you're talking of the electromagnetic radiation as a particle, we are talking about what? About the photon. Okay, right. And then a photon is a packet of energy. Photons are packets of energy. And then the energy of a photon is related to the wavelength of electromagnetic radiation according to the following equation. This is the energy is equal to the Planck's constant times frequency, or energy is equal to the Planck's constant times speed over wavelength. Okay, right. I want you to write these 2 points in 1 minute, and then after that I'm going to give you more time to write other notes. Let's just write these 2 points in 1 minute, then after 1 minute we'll come back and continue with our notes taking. Right, welcome back, grade 10s. I hope you managed to write your notes then. Let's move on. Right, we said that this is the formula where E is for energy of the photon in joules. the energy of the photon in joules. Don't worry, I'm going to give you time to write the notes. And then H is the Planck's constant, and then this is the constant. Please write it, make sure you have this. We're going to use it in this lesson. And then F is the frequency in hertz. And then we have the lambda there for the wavelength in meters. Our wavelength must be in meters. And then, oh, we left something. What is C? C is the speed of light. C is the speed of light. What is the value? In meters per second, what is it? It is 3 times 10 to the power 8 meters per second. Okay, please make sure you have the values here for the Planck's constant and the speed of light. Let me give you 2 minutes to copy these points. Welcome back, Cretans. I want you to recognize something. Maybe some of you are aware of it. If you check, these formulae are just what? The same. Do you remember our wave equation? C is equal to what? C is equal to frequency times wavelength. Okay? C is equal to frequency times wavelength. Right, so it means here, from this equation, we can see that frequency is equal to C over the lambda over the wavelength. You see that? So now if we take this and replace this F with it, we are getting this. You see that? Okay, so these two equations are just the same. So it depends on which variables are you given sometimes. Sometimes you can even use any of them. You see that? We're going to be doing that in this lesson. The higher the frequency of electromagnetic radiation, the higher the energy. Please write it down. The higher the frequency of electromagnetic radiation, the higher the energy. It means there's a direct relationship between frequency and energy. Right, if you look at our electromagnetic radiation spectrum that we deal with, from the radio waves up to the gamma rays. Okay, the gamma rays have the highest frequency, and meaning that they have the highest energy. Remember also the relationship between frequency and wavelength. Okay, if the wavelength is shorter, it means the frequency is high. If the wavelength is longer, it means the frequency is low. So it means now there's indirect or inverse relationship between wavelength and frequency, this inverse relationship. Meaning that also between wavelength and energy, there is inverse relationship. Inverse relationship is a situation where if one variable increases, the other variable decreases. Do you know such situations? You see that when one variable increases, the other variable decreases. That's an inverse relationship. But a situation where when one variable increases and the other variable increases, then that is a direct relationship. Okay? Right. Now, so the higher the frequency of electromagnetic radiation, the higher the energy. Please make sure you have that with you. We're going to see that. We're going to apply that in some of the questions that come from past examination papers. So this diagram will assist us to see that here the frequency is high, but if you check the wavelength, trough to trough, crest to crest, you can see that it's very short, but the frequency is high. Okay, energy also is high. Wavelength is short. You see that? But when wavelength is long, frequency is low, energy is low. Okay? Don't forget that. Please have this point. Make sure you write it down. Now, that's the first calculation I want to give you. And I'm going to give you 3 minutes. Very easy. Calculate the energy of a photon with a frequency of 3 times 10 to the power 18 hertz. Let's do that in 3 minutes. After 3 minutes, we're going to mark our work. Let's do it. Welcome back, returns. Sometimes it assists me a lot to write the variables that I'm given and the variables that I'm looking for, just to list them down first. Then it gives me a clue of what formula I must use. Okay, so it says calculate the energy of a photon with a frequency of 3 times 10 to the power 18 hertz. So here we want energy. That's what we're looking for, isn't it? What do we have? We have frequency. 3 times 10 to the power 18 hertz. What else do we have, Cretans? Do we just have these two? We know the speed of electromagnetic radiation, isn't it? What is it? It is C. It's a constant, remember. So C, which is 3 times 10 to the power 3 times 10 to the power 8. Oh, I almost forgot. Right, meters per second. Okay, right. So it's 3 times 10 to the power 8 meters per second. And then if you check these three variables, which formula are you going to use? The ones that I gave you two formulae there. So which one are you going to use? Energy is equal to, oh, what else do we have? Calculate energy. What else do we need? I forgot also. The Planck's constant, H. Oh, this one will make our life even easier. We don't even need C there. The Planck's constant, what is it? 6,63 times 10 to the power negative 34. Okay, so this one we won't need this. So it's this and this. We're looking for this. So which formula are you going to use now? Which formula are we going to use now? We have the Planck's constant. We're calculating energy. Planck's constant, Planck's what? Constant. It's a constant, isn't it? So what is it? We're going to use energy is equal to Planck's constant times frequency, okay? And then we just substitute. So when you list your things like this, it helps you to see what you have, what you're looking for, and which formula you're going to use. Okay, right, and then now we can just substitute, use your calculator. It's a skill that you can undermine and think is that is not very, is very important. It is very, very important. Please use your calculators. Now I want you to calculate this. And the answer you get must be the same as mine. Because we may fail the exam because we don't know how to use a calculator. So let's use our calculators, everyone, and let's get our answers. What is the answer there? Energy is equal to what? It is equal to 1,989 times 10 to the power negative 15. We must get the same answer. If the answer is not the same as this one, then someone is wrong. Maybe it's me who's wrong or you, but we must get the same answer. If I'm wrong, please WhatsApp me and tell me, say, hey, your answer is wrong. Please correct it. Okay, I'll do that. I'll do that. So let's make sure that we know how to use our calculators. Okay, right. Was that difficult? Not difficult. Physical science is not difficult. Very, very easy. Okay, get the correct formula, substitute correctly, get your answer. Okay, are you ready to do the next one? Let's try the next one. Right, what is the energy of an ultraviolet photon with a wavelength of 200 nanometers? Okay, how many minutes do you need for this? 3 minutes will be enough. Let's try it. Right. Welcome back, Cretans. Did you manage to get it right? Let's list our things, the information that we have, and the information that we're going to be looking for. What is the energy? That's what we're looking for. We put a question mark. We're looking for energy. And then in ultraviolet radiation, in ultraviolet photon with a wavelength, oh, we have wavelength. Oh, but the problem here is in nanometers. Remember when we wrote those points, they said you must write. We said wavelength must be in what? In meters. Those units are very, very important. You have to know the frequency must be in this. The speed must be in this. The wavelength must be in this. The wavelength must be in meters. So a wavelength should be, so it's going to be 200 times 10 to the power -9 meters. Okay. Right. What else do we have? Do we have something else? We have the speed, the c. So c is equal to 3 times 10 to the power 8 meters per second. Do we have something else? We have it. What is it? The Planck's constant. What does it say? The h is equal to 6,63 times 10 to the power -34 joules second. You know the units for Planck's constant is joules seconds. You know that. Okay, right. And then which formula are we going to use now? Which one? Energy is equal to Planck's constant times frequency, but we don't have frequency here. Energy is equal to Planck's constant times c over wavelength. Oh, we have these ones. We have h, we have c, we have wavelength. We can find our energy. Okay, right. Now let's write our formula. This is the formula, and then we substitute. Okay, before I show you the answer for 1 minute, I want you to use your calculators. I don't want people are going to lose marks just because of a calculator. Okay, try use your calculators and get the answer. Let's do it in 1 minute. Welcome back, grade 10s. Did you get the answer? This is the answer. That's what I got when I used my calculator. Okay, we must have the same answer. Okay, please check. If you're getting something different, try to calculate again, get something different, let us know. But this is the answer. Okay, right, let's move on. So we've done the basic calculations when it comes to the energy of a photon. We don't have any other formula. We have these, okay? So now I want us to just go back and revise questions from past examination papers, and also some of the questions there will involve what? Will involve calculation, okay? Right. This is the calculation. Basically, this is what we are supposed to do. But just get questions from past papers. We are revising past papers and still going back to the calculation. Are you fine with that? Okay, let's do that. Now, this is paper 1, 2018, question 8. Okay, if you want to check that paper, right, this is the paper. I want you to see that these things are coming from what? From past papers. I'm not lying, okay? So the questions will be similar. The concepts, you see also that it's always about the same concept. Things may be put around in different ways, but it's just the same concepts. Okay, right. The types of electromagnetic radiation are arranged according to frequency in the table below. They are arranged according to what? To frequency. Don't forget that. Yes, we say they are arranged according to frequency. Right, but how are electromagnetic waves generated? If there's someone there, maybe raise your hand and give ma'am or say the answer. You say it. You don't need to write everything. Say the answer in the classroom. Right, how are electromagnetic waves generated? Raise your hand and say the answer. Don't shout. You are going to be making noise. One person at a time. How are electromagnetic waves generated? Where are these electromagnetic waves coming from? Okay, they are generated by what? Accelerating charges. Accelerating charges. Please write that one down. Electromagnetic waves. Electromagnetic. I'm going to be using the pen a lot today. Electromagnetic waves are generated by accelerating charges. You know what is to accelerate? When the car is moving at a certain speed, then you're accelerating. It means you're changing the speed. When you're changing speed, that's acceleration. Okay? It's not speeding, it's acceleration. Okay? Right. So electromagnetic waves are generated by accelerating charges. Okay? Write that one down. Write it fast. You can say, just say EM waves are generated by accelerating charges. Table below. It means increasing frequency. Now, what type of electromagnetic radiation has the highest energy? What type of the electromagnetic radiation has the highest energy? And then in the next question, you are going to explain why you are saying it is the one that is the highest energy, okay? Now, I just want you to tell me the type. Raise your hand. If you do not raise your hand, then you mustn't say anything. Raise your hand and say, if you're given the opportunity to say something, you say it. What type of electromagnetic radiation is the highest energy? Did you say the gamma rays? Or you said radio waves? Okay, it is the gamma rays. Why? That's our next question. Why is the gamma rays the ones, or why are the gamma rays the ones that are what? Are having the highest energy? Because they are the ones with the highest frequency. What did you say about the relationship between frequency and energy? We said there's a direct relationship. The higher the frequency, the higher the energy. So gamma rays, they have the highest energy, have the highest frequency, meaning that they have the highest energy. Okay? Right. Now, it's easy. This is a past paper. It's very easy. Do you see that? It's very easy to pass. It's very easy. A certain type of electromagnetic radiation is a wavelength of 600 times 10 to the power negative 10 meters. Identify the type of electromagnetic radiation by performing a calculation. That's the main objective for today's lesson, calculating these energies. Right, now, a certain type of electromagnetic radiation has a wavelength of 600 times 10 to the power negative 10 meters. Identify the type of electromagnetic radiation by performing a calculation. So I want to give you a clue. I want you to use this formula. Let's start with this one. Our wave equation. C is equals to F frequency times wavelength. Can you use this formula? And then in the next part, I'm going to give you the formula also you must use. Okay? Let's try to use this one. I'm going to give you 3 minutes. 3 minutes. Let's do it. Welcome back, grade 10s. Did you manage to get the answer? Which electromagnetic radiation is it? Is it ultraviolet radiation? That would be correct. Okay, how did you get that? C, we know what C is. 3, what is it? 3 times 10 to the power 8 is equal to the frequency. That's what you're looking for. Remember, I said you can list your things first. And then times, we put brackets, 600 times 10 to the power negative 10 meters there. That's wavelength. And then we divide by wavelength on both sides. It becomes 3 times 10 to the power 8 divided by 600 times 10 to the power negative 10 is equal to the frequency. Right, what did you get after calculating the frequency there using your calculators? Now you must know how to use a calculator. So frequency there is equal to 5 times 10 to the power 15 hertz. Okay, and then that is in this bracket. You check. So that is ultraviolet radiation. See that? Okay. Now, I want us to use another method, an alternative method. Right, we are given the wavelength, we know our Planck's constant, we know our speed of light. So now we are using the formula energy is equal to H over H times C over wavelength, isn't it? And then we're going to get our energy. And then after getting the energy, we can use our formula. Energy is equal to the Planck's constant times frequency. Remember, we want to get frequency. So we can get energy first, and then after getting energy, we can then use that answer to get frequency. You see that? Okay, let's do this together. So let's get the energy. It's going to be energy is equal to what? 6,63 times 10 to the power negative 34. And then times the speed c, 3 times 10 to the power 8 meters per second. And then divided by the wavelength. We're given the wavelength here, which is 600 times 10 to the power negative 10. And then the answer should be E is equal to 3,315 times 10 to the power negative 18 joules. Okay, right, I'll use this side. I don't have enough space here, so I'll use this side. So this is the energy. But remember that energy is equal to the Planck's constant times frequency. Okay, you see that? So we can substitute our energy there in Planck's constant, and then we calculate frequency. So energy, we got 3,315 times 10 to the power negative 18 is equal to the Planck's constant times frequency. 6,63 times 10 to the power negative 34 times frequency. Okay, and then what we do to get frequency, we divide both sides by the Planck's constant. So it becomes 3,315 times 10 to the power negative 18 divided by 6,63 times 10 to the power negative 34 is equal to frequency. And then what do we get? We get our 5 times 10 to the power 15 hertz. That's frequency. You see that? We're getting the same answer. So that's what we're supposed to do there. Okay? Right. Let's move on to the next question. Okay, so then after that you must conclude. Remember, you must let's see. Remember, you must answer the question. It says identify the type of electromagnetic radiation. After that, you must name the electromagnetic radiation, which is ultraviolet radiation. A certain type of electromagnetic radiation was wavelength of what we have calculated. We have identified our type of the EM radiation there. State one application of the type of radiation identified in question 841. Where do we use ultraviolet radiation? Right, we talked about this. We said they're used to sterilize medical equipment. What is to sterilize? To kill the pathogens, what do you call them? Pathogens and what? Bacteria, virus, and all those things. Okay, so ultraviolet radiation is used to what? To kill those microorganisms, okay, that can cause diseases or transmit diseases from one person to the next, isn't it? So they have to kill those microorganisms. And then the other thing, sometimes we have seen when people are checking money, okay, if they want to check if the money is genuine or is fake, they put it under the ultraviolet radiation. Then you start seeing other things that marks there. Okay, you see that? So it's used there for checking currency, like money. Okay, and maybe there are other uses of ultraviolet radiation. You can even check those, and if it's appropriate, you'll get your mark. Okay, I'm not saying those are the only uses. And then there's this 2016 paper. Different types of electromagnetic radiation have different frequencies, isn't it? Right. This can influence their properties and what each could be used for in our daily lives. Choose the frequency from column B that matches the type of electromagnetic radiation in column A. Write only the letters A to C next to the question number, and then we're given an example of how we can write this. So we must know how to arrange our EM radiation from radio waves up to what? Up to gamma rays, isn't it? Okay, right, you must remember that. So now if you check here, the one with the lowest frequency is radio waves. So it goes there, and then followed by ultraviolet radiation, it goes there, and then gamma rays, it goes there. You see that? And then they said we must write like this. Please don't start drawing lines here, okay? They said we must write like this. So ultraviolet radiation is C. So you write your C there. Gamma rays is A. You write your A there. And then radio waves, B. You write your B there. Okay, please follow the instructions in the examinations. Make sure you follow the instructions, okay? Right. And then, what's the next question? Write down one use of each of the following types of radiation. Okay, the first one, you mustn't forget it. Okay, infrared, where is it used? Where is it used? When I say infrared, I usually think about the people, fans, soccer fans, they like the remote when it comes to watching soccer, isn't it? Remote controllers. TV remote controllers. They use what? Infrared radiation. And then this one is easy, microwaves. We use microwaves to warm our food and all those things. And then there are also other uses, isn't it? Okay, just remember some of those. You can also research on this, just interesting. Just know where is infrared radiation used, microwaves. Don't think about the microwave only, isn't it? Okay, right, now, okay, let's just discuss. We're left with 5 minutes. Let's just discuss, okay? I'm not going to be giving you time to write anything. We are discussing now, okay? Right. Remember our WhatsApp line 079 578 2908. If there's any question, please send us those questions. When doctors need to establish the seriousness of a fracture, a picture is taken of the broken bone. The picture below shows a fracture. Okay, some of you are going to be doctors. It's going to be interesting. This is how we're going to be seeing people's bones, isn't it? Okay, what do they use? So, name the type of radiation used for this procedure. What do we call it? It's even called, we call it using those, the name of that radiation. What is it called? It is called the X-ray. Okay, very, very easy. X-ray. Okay, right. Now, property of this type of radiation which enables it to perform this procedure. I want someone to raise a hand there in the classroom. raise your hand and say the answer. Which property, write down the following, the property of this type of radiation, which enables it to perform this procedure. Which property is that? Raise your hand and say the answer. Right, the X-rays are able to penetrate soft tissue of human beings, soft tissue like this, our skin, the meat there around the bones. That's tissue, isn't it? We talk about the cells, tissues, organs, and all those things. We did that even in grade 8 and 9. Right, so the X-ray can penetrate soft tissue, but when it comes to the bone, it cannot penetrate bones. So that's why we are able to see the bones inside the flesh. Okay, X-rays can penetrate soft tissue of human beings. Right, and then 833, again raise your hand and say the answer. Danger of overexposure to this type of radiation. What is the danger of being overexposed to X-ray? Say the answer. Okay, we may have different answers, isn't it? Because there are a lot of dangers. Okay, it's okay. So things like, think of skin cancer. Okay, cancer. Some of them, they are called ionizing radiation because they do change our cells. They do change our cells. So you are not supposed to be overexposed to them. Okay, right. And then a radio program is transmitted in the FM band on a wavelength of 3 meters. Calculate the energy of a photon of the radio wave. Right, I'm going to give you 2 minutes, and then this will be the last question that we're doing. Let's have 2 minutes, and then after 2 minutes, we mark our work, and then we'll be done after that. Let's do this in 2 minutes. Right, welcome back, grade 10. Sorry for the time, I made a mistake. We still have time. I think we have about 10 minutes, so we are going to continue up to 1:15. You see, I checked my time there, I saw 11 o'clock, and then I thought, oh, the lesson ends at 11 o'clock, okay? We have to be here up to 1:15, okay? So let's continue. We're going to move slowly and make sure that we understand, okay? Right, a radio program is transmitted in the FM band on a wavelength of 3 meters. Calculate the energy of a photon on the radio wave. So we're looking for energy. We don't know what it is. What do we have? We have wavelength. That's good. What else do we have? We can't calculate energy using wavelength only. What else do we have? We have the constants, isn't it? We have the speed of light, 3 times 10 to the power 8 meters per second. And then what else do we have? We have the Planck's constant, remember? H is equals to 6,63 times 10 to the power negative 34 joules seconds. Okay, right. And then what is the energy? Let's calculate the energy. So we use our formula. What does the formula say? Energy is equal to H, the Planck's constant, times C over wavelength. Okay, right. And then energy is equal to the Planck's constant, which is 6,63 times 10 to the power negative 34. Okay, times C is 3 times 10 to the power 8 meters per second. And then over the wavelength, 3 meters. Okay, you see that? Right, and then, let's put our calculator. I was just putting units there. Okay, it's fine. I'll also talk about units, the importance of units there when it comes to these calculations. Right, let's put this in the calculator and we try to get our answer. What is it? The answer, I got an answer here. What do I have? I have 6,63 times 10 to the power negative 26 joules. Okay, so the units are very, very important, graders. They are very, very important. If you check, I want to put the units only and see how important they are. You cannot use your wavelength, which is not in meters. You cannot use your time, which is not in seconds. You cannot use, so the units there that must be used. You have to know them. Let's take, for example, this one. The Planck's constant we said is joules second, isn't it? So that is joules second. And then times the speed of light, which is meters per second. Meters per second means meters divided by seconds. Okay, you know your math, isn't it? We say 1 over seconds, just same as this. Okay, you remember that. 1 over x is x to the power negative 1, isn't it? Same thing. So this is like meters over seconds, and then divided by meters, the wavelength here, or this was meters per second, and then divided by meters. So again, the meters goes underneath because it's division. And then if you check here, meters divided by meters, seconds divided by seconds, what do you remain with? We remain with the joules that we're looking for. So make sure that your units are appropriate. You're given a wavelength, for example, in nanometers. You cannot use nanometers. It has to be in meters because the other variables are going to be in terms of meters. Okay, right. And then let's go to the next question. Write down 2 properties of electromagnetic waves. Right, 2 properties. One person will say the first property, the second person will say the second property. Okay, first person, raise your hand and say the answer. Okay, what is it? What are the 2 properties of electromagnetic waves? Okay, now the second person, raise your hand and say the answer. Okay, do we have the 2 properties? We should have those 2 properties. Remember, we talked about this in our previous lessons. We say that electromagnetic waves have what? A particle-like nature. 1. They have wave-like nature. 2. Remember, these are waves. They can be reflected. They can undergo refraction. And the other thing that I almost forgot, electromagnetic waves do not need a medium. They can propagate in a vacuum. They do not need a medium because They are self-propagating. Oh, it's another property again. They are self-propagating. The electric field induces the magnetic field. The magnetic field induces the electric field. So if you have mentioned some of those properties, that's good. Okay, right. And then let's go to the next question. I have another paper, I think. Oh, this is another paper, 2015 one. Okay, we're done with 2018 and 2016 one. Right, now, this is similar to the question that we once answered. I think it was the 2018 paper. This is 2015 paper. Which radiation has the highest energy? And it is a different question. You see, different papers. You see? Okay. So make sure that you do this. Get past papers. If you do 5 of them, every concept, because you do 5 of them, I'm telling you, you will get your distinction. You will definitely get your distinction. Okay. Some of these revision lessons that we do here, revisit them. Revisit these videos. Watch the videos. You will never go wrong. When it comes to waves, sound, and light, you'll see the mark you're going to get there. Okay? Right. Even when you go to the higher grades, you do the same thing. You will get distinctions. Right. And then, which radiation is the highest energy here? Do we say gamma rays? Yes, gamma rays. A certain radiation has an energy of 1,9 times 10 to the power negative 20. Identify the type of radiation associated with this energy for 4 marks. We can't just get 4 marks by just picking from the table. What must we do? We must do calculations. Let's do this for 3 minutes. Let me give you 2 minutes because we're left with 2 minutes. 2 minutes, and then after 2 minutes, we mark our work, then we'll be done. Let's do it in 2 minutes. Welcome back, returns. Do you recognize that this question also is just similar to a question that we did? But in the previous question, they told us identify the electromagnetic radiation by using calculation. But here they didn't tell us. They say identify the type of radiation associated with this energy. So you have to see that we have to do the calculation, isn't it? So now we have the energy. And then we have the Planck's constant. So it means we can get the frequency, you see, and then identify the electromagnetic radiation. Okay, so energy is equal to Planck's constant times frequency. Energy is 1,99 times 10 to the power negative 20 is equal to the Planck's constant 6,63 times 10 to the power negative 34 times frequency. Then what we do? Divide by the Planck's constant on both sides of the equation. You see that? Then divide. Then the calculator will do the rest of the thing. Once we just substitute and isolate the variables correctly, then we're done. You see that? And then frequency is equal to 1,99 times 10 to the power negative 20 divided by 6,63 times 10 to the power negative 34. Then the calculator will do the rest. And then what do we get? Frequency here is equal to, what did I get? I got 3,16 times 10 to the power 13 hertz. Right, which radiation is that? It should be here. You see that? Okay, so that is infrared radiation. Okay, right. Thank you very much, Cretans, for joining us. I really hope that you have learned something and you are going to continue learning. Let's meet next week for our other lesson. Goodbye.